So hello everyone, and thanks again for joining today. My name is Philip. I'm the Business and Sales Development Manager for StressHead and responsible for the CarboStress system. And it's a big pleasure for me to welcome you everyone today, and as well my colleague Ari from the part of Sika will start with this presentation today. Hi Ari, can you hear us?
Yes. Hi, Felipe, and good afternoon, everyone. Thank you so much for making time today to attend the presentation on post-tensioning with carbon fiber systems. My name is Ari Vokshi, as Felipe said. I'm a technical sales manager at Sika, United States, focusing on CFRP and corrosion products. As part of my roles and responsibilities include being a technical resource for engineers and contractors and supporting them on from bidding phase of the project all the way to coordinating it with design partners. I've worked with carbon fiber solutions for over 11 years now, and I'm pretty passionate about CFRP and specifically on this post-tensioning with carbon fiber. I hope you find this presentation helpful today as we go through some interesting slides and provide some great case studies.
Okay, just give me 1 second. I have here two people writing that they cannot hear us. Give me 1 second to check.
It's probably on their end, Felipe.
I guess as well. Everyone just check. I see here someone else writes that they can hear us sound clear.
I think we continue. All right. So just a few or just a summary of what the learning objectives for today are. We'll talk about why structures are strengthened. We'll talk about materials that are used for structural strengthening in general, and then we'll dive and focus more on the active post-tensioning systems with CarboStress, and then which is what Felipe will cover, as well as we'll dive into some really awesome case studies from across the world where the system has been utilized. A little bit as we start the presentation, I do want to mention a few things about Sika. Hopefully you're all familiar with us, but we've been around for more than 100 years, and we provide, we are proud of our reputation, quality, and reliability of that we provide through a comprehensive portfolio of technologies and solutions. We participate in various markets. You can go to the next slide. Including concrete, waterproofing, roofing, building finishes, flooring and coating, sealing and bonding, refurbishment, which is where CarboStress fits in, as well as the industry market. Within the concrete repair and protection, if you're in the US, a lot of these brands hopefully look familiar to you. We offer a wide range of bonding agents, expansion joint material, grouts and mortars, epoxies, as well as structural strengthening. And some of our brands for structural strengthening include Sika Carbodur, Sika Corab, as well as the CarboStress system. So now more onto the fun stuff and talking about the technical aspect of this presentation. So why do structures need strengthening? Well, in general, a structure needs strengthening because it has some sort of a structural deficiency. This could be due to some sort of insufficient reinforcement, could be due to corrosion damage, a change in use in building, structural damage, and a lot of times, of course, seismic upgrades as well in a lot of parts of the world. When we consider structural strengthening, there are several methods that are utilized. One is externally bonded FRP or steel. This is, I would say that 80% of the work that used to be done with bonded steel is now done with carbon fiber. These products now have been around for more than 30 years, and they continue proving that they're reliable structural strengthening method in the market. However, if you know about FRP, you know that there's limitations, right? They're not the solution for everything. One of them being that the existing structure has to be able to withstand some load. And so if that doesn't work, there's always a possibility for section enlargement. Obviously, we know the disadvantages to it, which is adding a lot more weight, having to increase the cross-sectional area of the member, etc. Other cases, external post-tensioning is considered. Mostly done, external post-tensioning has mostly been done with steel. The topic of the presentation today is how we can do external post-tensioning with carbon fiber as a unique method in the market. And then finally, if none of these really work, there's always supplemental supports, right? Adding I-beams to a member, adding additional columns, etc. So as we start looking into the post-tensioning solution, let's start from the beginning and define what this material is made of and what it is, right? So we'll start with the basics. So what is an FRP system? So FRP is used in the structural strengthening world. It stands for fiber reinforced polymer. In other markets, for example, aerospace, they mainly just call it composite. But it really, the FRP consists of a fiber or fabric, depending on how it's manufactured, and that's commonly carbon. Sometimes it's glass, but those are the two most commonly used fiber inputs for fabrics, which is glass or carbon. Then the resin. The resin, in most cases, is epoxy. There's unique systems out there that also saturate the fiber with polyurethane systems. But again, mainly we see epoxy. And then lastly, I do want to mention that when we're talking about composite materials, that reinforced concrete itself is a composite material. And as such, when we're adding another composite, right, another material like FRP, we're creating quite a complex system. So understanding how to design with it properly is quite critical in terms of having a successful strengthening. Now, the available FRP systems in the market, in general, there's a variety of them, but the main ones that we see is the wet layup systems. This is when you take the carbon fiber or glass fiber fabric and you wet it in the field, and then you install it on a beam, on a column, or what have you. And the main advantage to these products is that they are conformable to the structure, right? You can go around corners easily, like U-wraps, for example, for shear strengthening, or around a column easily. Another strengthening FRP method is pultruded plates. They're called laminates. There's different terms for it, right? The laminates are pre-cured laminates that come in a certain thickness and width, and they're bonded to a structure via epoxy. These are great for flat surface applications. They don't really conform to corners, for example, so they have their limitation. Near surface mounted rods, these are carbon fiber rods that are installed, again, for the purpose of structural strengthening by cutting a groove into the concrete substrate and then dropping them in more or less, and then sealing it all up with epoxy. These are very widely used, for example, for top slab applications when you have positive or negative moment cracking, or just in general crack stitching. We use these a lot. Post-tensioning with FRP plates, we'll talk more, but that's the focus of the presentation today, but that's another FRP strengthening method. And then finally, I want to mention the FRCM systems. This stands for fiber reinforced cementitious matrix, slightly different than your traditional FRP. This takes a carbon fiber grid-based material and you embed it, instead of an epoxy, now you're embedding it in cementitious matrix, offering breathability, offering a much easier application for wide surface areas, especially, for example, for masonry applications. So it's just a summary of what FRP systems are that are available in the market that you should be aware of. All right, so now let's start diving into the post-tensioning side, right? So what's the difference between your traditional externally applied FRP systems and externally PT FRP systems? So a standard epoxy bonded FRP system is considered passive strengthening, right? What that means is that the structure it is under some current stress, right? Then you apply the carbon fiber, and the carbon fiber sits there until a new load is introduced to it, in which case it engages and provides that additional strengthening. The PT FRP system is an active strengthening method. What this means is that the moment you install the PTFRP system, it automatically relieves the stress from the structure and adds additional capacity, right? But really the other main difference is that with the PTFRP system, we can address deflection, for example, issues, and you can provide much higher capacity compared to a traditional FRP system. And then, as I mentioned before, external PT has been traditionally done with steel, but we know, obviously it has advantages, but also with steel, it is corrosive. It's much heavy and more difficult to install. There's fabrication that's required and can be high maintenance. Whereas with FRP, we're dealing with a non-corrosive and chemically resistant material that's lightweight. Another interesting, very cool aspect about the CarboStress solution is that it has no creep and slip behavior from the test data that we have. It's very easy to install. You can get it on the field in unlimited length and just cut it to size in the field. And so those are just some of the main advantages when compared to traditional FRP. So I think with that, I'm going to pass it on to Felipe, who's going to dive deeper into the solution itself.
Thank you very much, Eric. As well, I would like to mention, I already see a couple of you have used the chat to ask some question or something was not clear. Please as well feel free to write any question down if something is unclear or you would like to have it explained more in detail. And we have space at the end of this presentation to answer all your questions. As well, very quick, a little bit something about StressHead itself. The company was established in 1999. So you see, we have almost 25 years of experience with post-tensioning the CFRP tendon. Our headquarters, the company was founded in Switzerland, but as we have this partnership with Sika, we have international activities. And to the right, it gives you a little bit an idea how we actually operate and work. So the idea is that in a very early stage of a project, we help the engineer, the owner with technical information, with drawings, with the experience we have gained from earlier projects, how the system can be installed and used for structural strengthening. But as well, a big part of our job is, as we know, it is a new system in the market. We really go to the job site, we help and train the contractor to install and, most important, post-tension the system correctly. And obviously, as we as well see in this graphic, during the whole process, we have the big support of Sika in our back. To a little bit give you an overview of what we have done, we can see in the last couple of years, we have had a lot of projects, obviously in Switzerland itself, but as well, we have been very active internationally. We had just last summer, about a year ago, our first project in Latin America, where we strengthened this bridge close to Tijuana for a heavyweight transport over 500 tons. And we're able to finalize the second stage of a very big project of 4 bridges in Slovakia by the end of last year. Now, the CarboStress system itself has a very wide range of application areas for structural strengthening. We can use it from bridge strengthening over to strengthening of industrial and high-rise buildings. We received lately a lot of requests for seismic upgrades, as there have been several changes in the codes. And as you can as well see in the last picture, we are able to install the system in a round shape to actually reinforce all type of silos or water tanks. Now let's talk a little bit more about the system itself. Our post-tensioning system has the same idea as a common post-tensioning system, meaning we have a fixed anchor on one side and on the other side, the movable anchor or the tensioning anchor, which allows us to apply the post-tensioning force itself. I mentioned earlier the partnership, and I would like to demonstrate this here in this picture. So the partnership that we have with Sika is that we only work with their material. The plate itself that we tension, or that is our tendon, is the Carbodur S626 plates. That means it's 6 centimeters wide and only 2.6 millimeters thick. And what we bring in this partnership is this head, which we can see on both sides of the tendon, which we call a StressHead, obviously where the name of the company comes from, which transmits the force mechanically, so meaning without any glue in between this tendon and the head, and finally transmits the force into the internal structure. Now for tensioning the system itself, as we can see, we install a standard hydraulic jack behind the movable anchor. Now by expanding that jack, we pull back here the head, which is fixed to those two threaded rods, which afterwards generates us this tensioning force in the tendon itself. The force is transmitted over the head to the anchor and finally generates us here this additional bending moment, which we are looking for in the structure itself. And the very important number is those 220 kilonewton or 50 kip. This is the final force or top force that we can apply to the system. Now, of course, if we do need a higher post-tensioning force, we can install whether the system next to each other or stagger them in several layers. I think this is pretty straightforward. Now, from there, we always have to ask ourselves, how can we introduce the force from the system into the structure? We have therefore designed several standard anchors, but as well as we're going to see, we have the possibility to design project-specific anchors to introduce the force into the structure. Our first standard anchors is this one, which we mainly use to reinforce concrete constructions. The idea is that we work with an anchor, sort of a shear pin. So what we do is first making a core drilling with a diameter of about 12 centimeters, and afterwards here insert this anchor with this shear pin, which the idea is that this anchor introduces all the post-tensioning force over that pin into the internal structure. Now as well, of course, depending a little bit on the requirement on the job site, the post-tensioning force that we have to apply depends on the perforation depth. We say in a concrete with about 3000 psi or 20 Newton per square millimeters, we need a perforation depth of about 8 inches. On the other side, we have this anchor here, which we mainly use for vertical reinforcement of masonry walls. So the idea is that we have two drillings through the ceiling and the anchor plate is on the other side of the slab. This gives us the advantage to introduce the post-tensioning force first into the slab and then already in a wider area into the masonry, that we don't have any compression problems with the lower compression force of the masonry itself. As well, in those cases, the big advantage of the system is, or of CFRP, is that it's so lightweight. Now, as you can see, of course, if we have to reinforce a building from the outside or a wall from the outside, we can just pass the tendon on the facade. Let's say we have to strengthen a stairway inside of the building. The only thing we have to do is making a local perforation. We can pass the tendon through those perforations and finally post-tension the building over the full height with one single plate. And a new advantage here is that the system is so lightweight, we don't require any heavy machineries, whether for the installation nor for afterwards the tensioning process itself, which most of the time we don't have access or the possibility to work with. And as well, to show you what I mentioned, we are able to design new anchor parts, which is a big benefit of the system. For example, on the left side, we see an anchor which allowed us to install two systems at the same time to the same anchor. Or for example, on the right side, in this project, we had the case that we could not make this perforation of a diameter of 12 centimeters. So what we did in this case, we worked with an anchor with a modification of this anchor with two shear pins with a much smaller diameter, that we did not interrupt here or interfere with the existing reinforcement inside of the structure. Now, to give you an overview of the installation and tensioning process itself, of course, first we define the location of the anchor. In the case of this anchor with this shear pin, some drilling and chipping is needed, and we can start to install the anchorages itself. As well, here in this case, we see we always will have a small gap between the anchor and the concrete construction. That's why we make an injection from bottom to top to really close this gap, that we can guarantee the force transmission between the two parts. Now afterwards, we always recommend installing the system bonded. This gives us two additional benefits. It gives an additional strengthening and stiffness to the whole structure, but as well, it's a very good mechanical protection for the system itself. So the idea is that we install and tension the system before the curing time of the epoxy. And you can imagine, as we have an enlargement of the tendon itself during the tensioning process, it is a very good protection for the tendon if it's installed bonded. Now, as soon as the epoxy is applied on the whole length of the tendon, we can start with the installation and tensioning process. So if here the view on the fixed anchor side, as you can see, the whole installation can be made under working condition, which was required, and the installation can be made by hand. Now we have my colleague Marcel, who is as well today in this call, and here on the other side, on this side is me. We really go to the job site and help and train the contractor to install the system. Now we can see during the tensioning process itself, we make safety steps. We don't apply the full force at once. We go in those steps and review that we don't have any corrosion in the system itself. We as well review the anchor parts and check that we don't create here any new cracks by applying this additional post-tensioning force or introducing the force to the structure. And here we have a detailed view during the tensioning process of the check or of the movable anchor. So as I mentioned here, the head is fixed to those two threaded rods inside of the anchor. And now we can see very clearly when we start to apply the force, we pull back the head. You can see this very clearly with the distance here that is getting bigger at the back of the anchor. We can monitorize the force that we are applying on the manometer that we have on the hydraulic pump. As well, we know the theoretical enlargement of the tendon. That's why as well we measure the enlargement, that we have sort of a double check. We of course write this all down in the tensioning protocol, which we will provide to the engineer and customer to ensure that the force is applied to the structure itself. And as you see, as soon as we finish applying or reaching that force, the required force, we only have to tighten those knots and the whole force is in the structure. Earlier, Eri mentioned already that we have no tensioning losses. We will as well see this at the end of the presentation in some tests. I would like to show this as well here. We don't have the same fixation as we know from the steel cables of this slip behavior, as we really just tighten the knots. The whole force is in the structure and the threaded rods afterwards, there's no movement. That's why, or one reason why we really have no loss of tensioning force even over time with the whole system. So as you see, it's a very simple system with the installation and tensioning process, but with a very great and big effect to the structure itself. It is an external installed system, so sometimes we have to ask ourselves, do we have to protect the tendon and the anchorage from fire? And saying so much, the system itself is not protected against fire, but there are several coatings or protection methods that we can install or that we can apply to prevent the system of being the first impact to fire. As well, in some cases, it is required to protect the plate of mechanical damages. For example, in this case, here we installed the system in a public stairway, and the engineer, as well as us, recommended the client to protect the plate from mechanical damage, meaning whether people could go and actually kids play with the tendon or make any harm with a knife and damage the plate. An easy solution, a small aluminum cover over the length and height of the system to just protect here the tendon from any damages. Now, about knowing a little bit about how the system itself works, I'm very happy or excited to share with you some references that you get a better understanding how the system afterwards really can be used in your daily life. I'd like to start with bridge strengthening with a quick overview how it can be used in those cases. So of course, we can use it if we have already an existing damage to the structure to give back this additional force needed. As well, higher loads and bridges designed 70, 80 years ago were probably not dimensioned for those loads we have nowadays. Or of course, as well, as the whole system consists of CFRP material, it is protected from corrosion. So if we are already dealing with corrosion problems, it's a very great solution as you don't have to worry after installation for a further corrosion of the system itself. The first reference I would like to show you is this project that I mentioned earlier from Mexico, that we strengthened the bridge for a heavyweight transport over 500 tons, which this bridge was not designed for, so we had to strengthen it for a change of use. We can see here in a plan that we received in a very early stage of the project request that we have had, or that there are a lot of pre-stressing cables in the beam, as we all know it from those type of constructions. So it was very clear from the beginning that we could not touch any of this area to introduce the force, because that's always the first thing that we ask ourselves, how can the post-tensioning force be introduced in the structure? And this picture here shows a little bit what we did. We worked with an anchor very similar to the one with this shear pin, with the difference that we made a complete drilling through the whole beam, installed here the anchor, afterwards pushed this shear pin through the perforation and to hold the anchor. And the anchor was designed this way that we could attach 4 systems at once, providing a post-tensioning force of 200 kip or 880 kilonewton per beam. And the very big advantage in this case was, we can see here, we only had very limited access to those beams on the very left and right of the section. And there was no possibility for heavy machineries for installing the systems. So as the system is so lightweight, we were able to pass the tendon here from one side, pull it over with a rope, install it as well in this anchor, and afterwards post-tension all the system without the need of any machineries, which would not have had space here on the scaffold below the bridge. I would like to show you here as well this project from Slovakia, where we strengthened in a first stage 3 bridges within 3 weeks with a total of 90 systems. And the reason for the strengthening was that the government bought heavier trains, which generated here a tensioning force in the lower section of the concrete, which in the European code is not allowed. So they needed an additional strengthening. And it was mandatory from the client that we did not interrupt with the traffic here below this bridge during the whole tensioning process. As well, in this case, you can see a lot of pre-stressed cables in those box girders. For this reason, we designed 2 special anchor parts. The one I already showed with those much smaller shear pins to introduce the force, and a second anchor which consisted of 14 chemical bolts which transmit the post-tensioning force over those bolts without that we damaged one of those existing span cables in the box girder. So here some further impression of this project or of the second stage where my colleague Marcel was by the end of last year to strengthen this bridge with a total of 90 systems in about 2.5 weeks. As well, here you can see in the last picture those chemical bolts that I mentioned, who we use to transfer the force without damaging the active reinforcement. So you can see a very big advantage of the system is that we can design special anchor parts to introduce the force without damaging the actual reinforcement itself. About now 4 years ago, we received a call from an engineer from France to strengthen or have a look at this project made out of this bridge made out of precast concrete elements. Now, the reason for the strengthening was that there was a car impact which damaged here one of the existing beams and destroyed not only the concrete section, but as well the whole reinforcement inside, so that our job was to give back this missing force to the structure. After a quick analysis of the forces, we realized that we will require two systems. So we decided to install them on the side of both of the beams where they were protected from further car impact, and to install the anchors on the very left and right side of the beam where we could introduce the force because the concrete in this zone was still intact. But by this, we realized that we could not make any drilling here in this zone of the bottom section of the beam, where was the actual reinforcement. We worked for this with an anchor, with a special anchor consisting of a shear bar, which had the dimension of 2.5 centimeters, so 1 inch on 1 inch in each direction, to transmit the force superficially without damaging one of the actual reinforcement here inside of the beam. In this picture, you can see the tensioning process itself. Before installing the system as well, we installed some wraps here in the middle section where the core impact took place, and as well here in front of the anchor itself to give back an additional force to the compression force to the concrete, as we have a very high superficial force introduction here from the anchor parts. And as the beam was very filigrane, we worked in this case with two checks to apply an axial reinforcement during the tensioning process itself. And here at the end of bridge reinforcement, one from Qatar. The reason for the strengthening here was that the construction truck crashed here against the bridge, destroyed one existing span cable completely, and opened the box girder over almost the whole length. So you can imagine in this case, we needed to give back a very high post-tensioning force in a very local zone. So in this project, we had actually the chance to work inside of this box girder, and we figured out to give back this high post-tensioning force in a local zone that we work best in applying the system in different layers. So what we did is we installed and tensioned first the shortest system, and then applied the system over the top of the first one. And to do so, we actually deviated all those systems. We can see it here in the bottom left. We created an epoxy saddle in front of the anchor to deviate all those 6 systems one over another. Now, as you have heard, as it is an active post-tensioning system, it can not only be used for structural problems, but also for serviceability problems. We have here a project from a VIP room in Casino. We have here on the left side this very big opening in the ceiling itself and those 2 columns in the middle of the room, which obviously the client wanted to get rid of. Now, the engineer who calculated this remodelation of this room figured out that it was not a structural problem, but simply the deflection of the ceiling itself would have been too big without any additional support. For this reason, we installed 3 systems, we actively post-tensioned them, and finally were able to take away those columns without too big of a deflection itself of the ceiling. Project where we used the system in a very similar way has been in this paper plant in Switzerland itself. The reason or for this refurbishment, for strengthening, was that they wanted to install a new paper machine to print larger amounts of paper, but the distance between those 2 columns was too small to pass this new machine. Now, in this case, we recommended making local perforation in the upper part of the columns. As you can see, we installed here the anchorages outside of the columns. We passed the tendon through those perforations, post-tensioned that beam, created new columns here on the outside, and were able to finally take away those 2 columns and one about 2 meters to passage that they could finally install this new paper machine. And a very big advantage in this project, or another option how we could have solved it, or the reinforcement could have solved, is by installing here simply a steel profile. The problem would have been that there would have been too much of an overhead height loose due to the installation. Now, as the system is so thin, only 2.5 millimeters, let's say with applying it with the epoxy, and we're talking about around 3 millimeters, you will have no loss of this overhead height due to the installation of the system. Now as well, I mentioned that the system can be used for silo strengthening or strengthening in a circular way. We just came back, my colleague Marcel, 2 weeks ago from a project in Israel, and here from the right side from a water tank in Tel Aviv. The reason here for the strengthening of the water tank was that there has been an insufficient reinforcement in the first place inside of the concrete, so that this freshwater tank suffered from a lot of cracks all around the silo, which obviously is not very ideal for a water tank. Now, they made a full refurbishment in the inside to close those cracks. And for a structural strengthening, we installed a total of 8 systems over the height of this silo to give back this missing force. As well as you can see, we work here with a special anchor type, which allows us to install 2 jacks to the same system and tension the system from both sides to reduce friction losses during the tensioning process. And by this application, the idea is kind of to install a belt or a tensioning belt around this silo to give back a compression force to the whole structure over the tendon itself. And as well, to give you an idea how the system is used for vertical strengthening or for seismic upgrade, basically the idea is that we apply an additional vertical force to result a much greater lateral strength in the structure itself. A very big project that we were able to install the system in such a way was in this high mountain clinic in Switzerland. As you can see here in this demonstration, we installed this a total of 160 systems over several floors, as well in a horizontal way to close joints between one building and another. In this case, even we embedded the systems in the wall so that they would not be visible to the clients of this high mountain clinic. And at the end, I would like to show you here this project again from Switzerland. The reason for the strengthening was that this building was made out of precast concrete elements as high as 1 story, and there was an insufficient reinforcement in the coupling joints regarding earthquakes, so then it needed an additional strengthening. Now, very smooth solution that we were able to provide was installing here the anchorages on the rooftop and in the basement. We're able to pass the tendons and install and tension single plates over the height of the full building without interrupting the tenants living in this building itself. And we're able to tension or to reinforce this whole building in just a couple of days without any interruption. Now coming slowly to the end of this presentation, a couple of words to the test and design of the system. We work very closely with the University of Lucerne, where we have a lab where we can try any type of special anchors or tendons if this is required. We as well made a fatigue test of 2 million cycle in the University of Milan to know the behavior of the system. And we have a long-term test where we overtension the system of 10% to know the behavior in the next years. So as you can see, we started here in 2009. Of course, we have a little bit of more movement here in the first year, or it's visible more movement because the next step here are the next 9 years. Now we made the evaluation after 10 years and extrapolated the behavior to the next 50 or even 100 years. Now, as you can see, the tendons that we installed were 10 meters long, and if we're extrapolating the behavior to the next 50 or 100 years, we are below 2 millimeters of relaxation of the system, and this number is insignificant to the force that we are applying, why we can really state we have no loss of tensioning force over time. And we remembered what we saw earlier. One of the big advantages is that we really just tighten those knots on the threaded rods and don't have this slip behavior, which we all know from steel cables itself. Now I mentioned that this whole presentation is going to be recorded. I will send you an access link afterwards by email along with this whole presentation. If you're interested in further information, we have as well, of course, a design concept and the technical documentation, which we are more than happy to share with you. For the end, I would like to give you a quick takeaway or resume of the whole system. The system is very lightweight and fast to install, meaning it has great benefits or great application if we are working overhead in a limited space where we don't have access. It's a very great choice of system. Mentioned this early enough, the system is free of corrosion, which is a great benefit as it is installed externally. And we have over 20 years of experience of the installation with the system. So if you have a project where you think this could be a solution or you're simply interested in a second opinion, feel free to reach out to us and we're more than happy to provide you with a free project proposal as well a cost estimate that you have an idea and something to present to the client how the system can be used to strengthen the structure. And I would also like to mention that we have planned a roadshow and we're going to the US in a couple of weeks, visiting the cities of Washington, Philadelphia, Boston, and New York. If you're in the area and you like this presentation, please feel free and contact me. You can see my email address, vonholsten@stresshead.ch. I would more than happy to come by to your office and present the system to you and your colleagues in a personal presentation. Now as well, here to the end, thank you very much for all of you guys. Amazing with around 70 people joining. It was very great talking to you. You can find the contract address as well of Eri. And if you do not already follow us on LinkedIn, follow StressHead on LinkedIn. We have a newsletter as well there, which you can subscribe for, which we post every 2 weeks. Very interesting news about ongoing projects all around the world, that you stay up to date what's going on with StressHead and the CarboStress system. Now, Eri, I saw that there are a couple of questions. I saw as well with one eye that you have been already busy like a bee responding them. Do we have anything still to cover?
I think, Felipe, one good question that came up that I probably you should readdress it for everyone on the call was the question on who will do the design using the system, and what are the steps for coordination between the contractor, StressHead, and the team prior to execution?
That's a great question. Thanks a lot. So there are several ways how we work. We have standardized anchors, where we have already made all the calculation, which basically the calculation left is the post-tensioning force that we need, and will the structure be capable to absorb this post-tensioning force, let's say, with this shear pin. Afterwards, if we see we have to work with a special anchor design, there are two ways. Whether if you feel comfortable yourself with steel calculation, you can make the calculation yourself. On the other side, we work very closely with an engineer from Switzerland. Unfortunately, and due to insurance reasons, we are not allowed to make calculations ourselves. But we have an engineering office which is very familiar with our system, which can provide you with a design of an anchor. So depending a little bit on the project, how the anchorage looks like, how the designer who will be responsible for making the design.
And then how do you support contractors on site?
We will go to the job site and we will prepare a method statement, which we will send beforehand, that all the preparation works will be executed correctly. Afterwards, for the installation, for the preparation of the tendons and the installation and tensioning, we will go to the job site and support the contractor during the whole tensioning process on site.
Okay. One question that I didn't get to, it says, how do you protect the anchors from corrosion?
It's a very good question. Yes, I forgot to mention them. The anchors itself are hot dip galvanized, or if it is required, they can also be fabricated and made out of stainless steel, that really the whole system is protected from corrosion.
Good. Another great question just came in. It says, what do you do when the concrete construction, like a beam or bridge, is pre-stressed and bending upwards? Do you manage the leveling with a mortar or what? This
exactly.
is, yeah, similar case to the Slovakia project, yeah.
Exactly. We had this case as well in Slovakia. This bridge was built in sort of a round way. So as we are always looking, the force transmission itself, different as in a passive system, takes not place over the bondage itself. But we always look for having a straight connection to the surface, that, let's say, not you could go, or we just have a vibration in the tendon, or animals or birds could go and nest inside. So what we did in this case is leveling out those sections. I maybe can show it to you in a picture. You can see it here. They leveled out in all the main kind of strips where we installed the systems, that we had a straight connection or a direct connection over the whole length of the tendon itself.
Perfect. One other question. For building, it helps, I guess the question is, will the PT system help the buildings for local strengthening only, or does it affect the global performance? And I think, go ahead, you try, and then I'll give it a shot too.
I think it depends a little bit in what cases well, if we apply an additional post-tensioning force to the system, we are changing the whole behavior of the whole structure. I think the correct response is more towards the global behavior of the whole structure, how the loads will be behaved. It depends a bit. Are we installing the system for seismic upgrade in vertical strengthening, or as well more horizontally to just change or make a new building with an old building to connect or behave kind of like a monolithic block? But as well, there again, it's more towards changing the global, let's say, structure of the whole building, how it behaves.
Okay, I think you covered it. That's what I was going to add. It depends on the application. Okay, And then, do you work on the side of the beams? Is that an alternative if it's bending upwards? So it's the same gentleman that asked the earlier question about if the structure is warped upwards.
So yeah,
So,
we.
do you understand it?
No, I'm not. Let me see the question.
So let's say the beam is curved with where it's upwards bended, similar to the picture that you have on the screen. But if it's a beam, they're asking, can you instead install the plates on the side of the beam rather than using a mortar to kind of flush it out, make it flat?
Absolutely. The system could whether be installed in the bottom section of the beam or as well on the sides, as you, for example, have used it in the project of France. That depends where we have a better access to the system or where it makes more sense to install it itself.
And they had one more comment, but I'm not clear. It says, I know we can not use the CFRP capacity fully out then. I'm not sure what that meant. Okay. Can this system be used to post-tension cylindrical containers or silos?
Yes, absolutely.
Deviated loop tendons.
How do you mean deviated loop tendons?
That's for silos. That's what they are. That's how they're reinforced. They're deviated loop tendons.
Yeah,
I don't. It just answered the question if you can do the post tensioning. So yeah, don't worry about the last part.
Absolutely, the system can be installed in a round shape. There's a minimum radius of about 2 meters that we do have to take into account. So we cannot just, let's say, reinforce a column with the system. Although we have a second system, it's called the CL restrap, where we can actually strengthen much smaller radius. And with the CarboStress system itself, for circular strengthening, we need at least a radius of 2 meters.
Which is 6 feet, approximately. 5.6 feet. Okay, why? One other question says, why not use rods in a small groove instead of plates? Wouldn't that have saved space and require smaller anchors instead of the plates?
Until this moment, we just have this system where we're working with the plate itself, and we don't have any system where we tension a rod, which would allow us to tension any. I think the easiest solution or answer to this is that we don't have a system for this.
Yeah, no such system exists, exactly. Does this system, is the system applicable to steel structures as well, or only upgrading concrete structures?
No, the application area itself is rather limited to, let's say, concrete or masonry. We can use it for steel structure as well. We can use it for wooden reinforcement. The question is always, how can we introduce the force? Because of course, even like talking about wood construction, having a much less compression force itself, but it's not limited to those materials that we have seen here.
I think that covers pretty much it. Everybody's thankful and they say it's a great presentation. There are a few comments about receiving a copy of the presentation, which I know you will send, as well as PDHs. So I'm not sure how you're going to manage that part, but
exactly. The PDHs, for those of you who have inscribed over LinkedIn and have accepted to send us news, we will provide everyone who's located in the US with a PDH. If someone joined not through the LinkedIn link, please send me again here. You can see my email address. Please send me an email address. Send me an email that we can take your data and provide you with the PDH point.
You know, Felipe, I missed one question and I would like, I'm not sure if we can address it. I think I have an idea, but there was a question where it said that when we did this presentation for the US, we included a case study for Ohio DOT, the Ohio project. And so the question was, how did we coordinate that with the DOT? And now a question just came in. It says, is this approved method for bridges by DOTs in the US?
The system itself is not approved by the DOT. I guess that's the straight answer.
Yeah, let me touch base on that. So most carbon fiber applications are usually, there is no approval process, right? The spec is usually, it goes into the special provisions, and then it includes properties and material requirements in there. So in this case, we can help with a spec for the DOTs. But as with all other FRP system, as I mentioned, there's no place in the spec that this would quite fit in. With regards to the Ohio project, that's really how we went about it, is what I'm mentioning now. Is the project came about because they needed something quick to be resolved, and the DOT team was on board, and we helped them with the specification to put it out for bid, and then that's how it got executed. Is it allowed by DOTs? Yes, I mean, all DOTs that we talk to are very interested in it. Absolutely. There's nobody that has said no, I guess. There's a lot of interest. Yeah, for sure. Yeah, no problem.
Great. I think if that has been everything as well, and if someone is in this area and would like us to come and visit, feel free to contact us. Eri, thank you very much for joining as well. All of you guys.
My pleasure.
It was amazing. Great to see so much interest. If you have a project where you think the system could be a solution, feel free to reach out. We're more than happy to give you a proposal and have a look at your project, to consult you or give you an idea how the system could be used for structural strengthening. And if anything has been open, any question, feel free to reach out in any case.
Thank you all.
Thank you very much, everyone.
Bye-bye.
Thank you.
Take care.
Bye, guys.